The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Karen, do you remember a few months ago when we had that super solder episode?
Yeah, you were having a kind of a rough week, so we decided to let you solder for an entire day to calm your nerves.
Yeah, and it did calm me down. I actually like soldering things, even if it is intricate and confusing. What we did was we took an Atari 2600, pulled the chips out of it, put those chips onto a separate PCB, and wired the entire circuit manually.
You know, we should do something with that. Maybe make it portable?
Oh yeah, I've never made a hand-wired Atari portable before. We could try to make it as small as possible and build a custom case around it using 3D printers and come up with a portable Atari. That sounds like fun. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Here's where we're at with the portable Atari 2600. I have it wired up here. I was using a breadboard to test the video circuit, which I have dialed in, and now that has been built in down here. The surface mount resistors actually create the circuit needed to create composite video. And then I also rewired the crystal up to the clock input over here, and this is the color timing potentiometer. But everything is still pretty flat. Then here's the cartridge slot. I found Frogger, which is my favorite Atari 2600 test game for a couple reasons. It has many colors on screen when you turn it on, and it plays music when you turn it on, so you can test color and sound immediately. A lot of old Atari games are kind of monochromatic or a big black screen. Okay, and then I have this 4.3 inch cheap backup camera that I got online, and we're gonna use this as our display. And everything's running off 5 volts. So let's see what happens. Pow. Oh, there it is. All right, there is the Frogger display. I can switch this power supply to show it is consuming 640 milliamps. It's not too bad. It's probably 60% Atari, 40% LCD. Remember, this Atari is, this technology is almost 40 years old, so it's not super efficient. So I'm gonna do another test. I'm gonna hook this up to a lithium-ion battery booster. I've attached a lithium-ion battery to this combination boost charge circuit here. So you can plug in a USB cable and 5 volts to charge the battery, and you can also boost the battery 3.7 volts up to 5, which is what we need for this project. Let's see if it works. All right, so we have both the screen and the old ancient Atari circuit running off this battery. We should probably check what the current draw is though. I know we've gone all this before, but just really briefly, if you want to detect the current, I'm going to detach the positive lead, switch my meter over to current. All right, and then you basically put the multimeter in line with the circuit. So I'm just going to switch it on and then tap this here. That should turn everything on. Okay, so the reason I'm doing this is because the current draw from a small battery that's been boosted will probably be higher than the 5 volts coming off that power supply there, and indeed it is. It's almost 1 amp. The important thing to think about is it's not drawing 1 amp at 5 volts, it's drawing 1 amp at 3.7 volts. So it takes more current to get the necessary current or power out of the battery since we're doing a boost. But it's still within acceptable parameters. All right, disconnect that. Always gotta be really careful when you're desoldering the lithium-ion batteries because you don't want to short out the leads with your iron. Okay, the 3D printers are both running to try to get all these parts done in time. This is the right half rear, and that's where I'm going to put the battery and the charger. So this was my test piece. I guess I'll put that in the 3D part giveaway bin for kids. And this is the real piece. So we can get at the charge jack here. The power switch will be down here. All right, and the battery will fit here. So I'm going to use double-sided tape to put these things in place temporarily. Felix is actually making a run to get some size 2 machine nuts. And then we'll just try to get the power section of this device all bundled up into one unit. Got a few more parts printed. This is the front end half of the left side of the unit. The D-pad is gonna go here. So before I get too much further, I'm actually going to glue this part to the main case. Again, I'm kind of designing this as I go. So these tines out the front here that I'm holding with my fingers, if I hold these down, that ensures that this part of the case is perpendicular to the main cartridge area in the center there. Once I have this in place, then what I can do is I can wire in the Atari down there and then hook up the cartridge slot down there. So the wiring between the Atari and the cartridge slot I made, much longer than it needed to be, because I'm actually going to rewire all these connections to the minimum length once I have the components in their final positions. So yep, I'm just gonna let this dry. Super exciting stuff. I've rewired the cartridge connector to be the minimal length required to actually fit. That's why I started with it really long so I could shorten it up. So what I need to do now is see if everything fits. So this should snap into place. There we go. Now the tricky part is this cartridge connector. I should have actually put it in first because all of these wires have to fit in the channel so the cartridge doesn't push against them. It's like thread in the eye of the needle. It's a bad fish. You'd best start believing in bad fish, Miss Turner. Well, I think I've come across a problem here. So this is an Atari cartridge circuit board as it fits inside of the shell. So the IC is always up, right? So this is how Frogger would plug in. And with Asteroids, it would plug in like this. But I think at some point along the way, it got flipped or I forgot to flip it. See, I always intended this to go in like that. So the cartridge label is facing out. So if that's the case, that means this piece here would insert like this. The problem is that appears to be upside down because, well, the way you can tell is there's two power connections right here and here, but they would be flipped like this. So it's not just the way this card edge connector is oriented inside of this plastic shell, it's also the way it's wired. So that's not good. I'm gonna have to figure out what is the least worst option here and then go with it. Here is why I wanted to have a big gap in the cartridge holder, because otherwise I can't install the cartridge slot, which I had to rewire, unfortunately. So the wires here will fit in the slits that I've created. All right, and then there are some screws that I've already installed into the cartridge slot that we should be able to drive and countersink, unless of course the screwdriver is too large. Use the old screwdriver. It always works, except for when it doesn't. All right, let's see if this cartridge goes in. Let go of your fears. Yay, it fits. No damage though. Okay, I'm gonna tighten these screws a little bit more and then we'll give it a test to make sure it works in this configuration. Let's talk shop.
Hi, I'm Karen, and I am going to talk to you today about organization. So before I came to the show, it was just Ben and Felix using the tools, and when it's just two people, they sometimes would just keep their tools off to themselves in their own personal areas. But when I got here, I was always looking around trying to find tools, and there was like 6 different places they could be, completely unorganized. There was not one place for a screwdriver. There were many, many places for screwdrivers. And sometimes I'd be looking for a tool and I didn't even know if we actually had it or not. And so finally, I got fed up and I convinced Ben to organize. And we decided to buy this lovely bin cabinet over here. We also utilized a pegboard for certain items. Not everyone has the money to organize in bins like this, so sometimes you can find objects around your house, maybe leftover food containers, or sometimes people cut off the lids or the tops of bottles, plastic bottles that you might have around the house. You can use those to sort things. You can buy small bins like this. You can get these in the fishing tackle section. You can get these in the bead section. You can frequently get them. I usually get mine for like $1.50 or $2 at like Michael's or Joann's. These are really, really useful for small parts, hardware, and you can write on the top like this, but it's also a good idea to write on the inside and the lid, so that when you have it open, you know what your part is. You've got a little map of what it is, kind of like those Valentine's chocolate boxes. You're like, does this one have the peanut butter or is it caramel? And then you're like, oh no, it's coconut. Don't want that to happen. So remember, having an organized and well-labeled shop will keep you more efficient, and you'll waste less time looking for things so that you can spend more time working on your builds. We'll see you next time.
And now, back to the build. I used the laser cutter to make this plate for the controls, and there'll be one on the right-hand side for the trigger button as well. So I have these surface mount tack switches, which I've just super glued in place. And this will attach to the underside of the front pieces. And there'll be just enough of a gap that the controls can sit on top. And then of course, there'll be a laser cut front piece. And I put a screw in the back of the D-pad to prevent it from pushing all 4 buttons at the same time. So I'm going to screw this in place and then wire it. That way I can wrangle the wires using the gaps that I have. I've got this PCB here. I've attached some slide switches to it for the left and right difficulty and attached a 10K potentiometer for the volume control. And I think I'll actually build the audio amplifier circuit onto this board as well. But for now, I'm just gonna make sure it fits in place. So we had a discussion today. Batman fell into a cave filled with bats and therefore became Batman. What if something else had been in that cave? Would he have become Rat Man, Sloth Man, Hobo Man, if there was a hobo in the cave? All right, so we got a little speaker. Felix pulled it out of a netbook or something. I think we can probably put that here and then have enough room for the amplifier circuit as well. Once I have these front panels both the way I like them, I'll get them wired up and then laser cut a front piece. But I'll probably laser cut that last. I want to make sure everything lines up first. And then we have a tack switch here for the main trigger. So I'll wire up the tack switches and add some hot glue around them to make sure they don't move. And yeah, it should work out pretty well. Okay, so the LCD, I tried to flatten as much as I could, but these 2 capacitors stick out a little bit, so there's 2 things we could do. A, we could put this in position and mark off where the capacitors collide with this back panel and then actually cut pieces out of this back panel. The other thing we could do is to actually remove these capacitors and put them off to the side, make this a little bit thinner so it sits flush without having to remove any more material. Moving the capacitors is probably the easiest way to do it because I think aside from those electrolytic capacitors, I think it would all fit. Yeah, here's like the crystal, it would fit. Here's one of the chokes, it would fit. Yeah, I think I'll just move these 2 capacitors. All right, I'm gonna hinge this at the top so it will go together like that. Again, I always try to make sure I know how the thing's gonna open up like a book when I put it together. So I'm gonna run this cable down to the input-output chip, then I'll run these wires down and across, and that should work. We have a pretty decent amount of space behind the screen. The main thing protruding on the screen are a few capacitors, which I've moved down, as you can see. So we got a pretty good amount of free space up here. So anything I have to run across the 2 sides, I will do over this area here. All right, time to get soldering. I'm going to attach the LCD next and then the power so we can actually see if everything's still working. So we've got the composite video and then power ground. Again, everything I wire, I want to do in such a way that I can close everything up nicely. Earlier, I added this piece of plastic behind the PCB on the LCD. I did that because when I stick wires through the holes like I just did, I don't have to worry about them touching anything because there's just a piece of plastic behind it. Great, now I've got the Joseph and the Amazing Technicolor Dreamcoat soundtrack stuck in my head. Come on now, Joseph, you know what they say. You're gonna make it someday. La 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 la. I'm gonna sell you into slavery because I hate you, Joseph. So what I am doing now is attaching 2 sets of power rails from the charge circuit. One is going directly to the LCD, and the other one will be going the Atari itself. I'll probably loop them both across the cartridge connector. I just have to make sure I don't hit these capacitors, but I should be okay. You and your dream code ahead of your time. Okay, I've got pretty much everything together. Here is the overview. This is the charge circuit and 5-volt boost. Right now I'm charging it up over a USB charger plug. The lithium-ion battery, the 3D printed custom cartridge connector here. That goes to the hand-soldered Atari 2600 board, which has been drastically shrunk. That connects to our controls on the front panel here, and our LCD is here. All right, so I'm gonna see if this all folds up and fits, and then we can try playing it. Well, we finished the new Atari 2600 portable. The circuit that we wired up for the Super Solder episode is now being used for something. Want to give it a try?
Okay.
Oh, let's unplug the charger.
Does it need to be off to be unplugged?
Probably.
It's a good idea. Okay. On.
Yay!
What game do we have here?
Commando. Oh, I'll do the music for this one.
Ooh, do I want those? Those good things?
I guess.
Those look like good things.
I think they're like cans of Spam.
Is my goal just to reach the top?
I think you're stuck in the tunnel.
Oh, I was stuck in the tunnel.
These graphics are pretty cutting edge for the time.
There's purple.
I know, and palm trees. There's clearly no doorway you just came in.
I like how all the aliens kill themselves.
They're robots, not aliens.
Oh, I like how all the robots. How do you know?
Because
say so on the box.
Just like at the end of AI, artificial intelligence, they're robots, not aliens.
Gosh. Trying to shoot me through a wall.
He's doing like a Tom Cruise run where his legs are going way faster than he's moving.
Why can I not do this one?
Because you missed. There you go. One more to go.
Do I not have that range? Oh, oh! Wow, look at that. He was just like rapid fire killing me there.
Wait, now you're in a completely different screen?
I think this is the first
This
level.
is really confusing.
Yeah.
Now we can play Atari in any location.
Ooh. So is it perfect or is there something you would change?
I never say anything is perfect. So we kind of designed this one piece at a time. We designed this, then I designed this, then I designed this. So yeah, the case could go together a little tighter, but again, we ran out of time. I kind of wish it had a bigger battery. And the battery charging circuit, I think we're not using it quite right because when you let this thing sit, it tends to discharge.
Ooh.
I think a little bit of current is being drawn by the circuitry. Not enough to power it, but enough to drain the battery. So I think we probably actually need to change how the power switch works, but we can fix that later.
Okay.
The D-pad, as you mentioned, is a little wanky.
Yeah, I don't think it should spin.
But maybe what if it could be the paddle controller? We could.
I think there should be like a lock. I don't know.
Right. Well, the way to fix it would be to me like a cross pad.
Yeah.
But remember, we had to recut this like 4 or 5 times. I just didn't want to recut this again. That's why I made a circle. Yeah, but the size of it worked out really well. Like I've always wanted to make an Atari where the cartridge fits down the back. I mean, the cartridge takes up a lot of space, so we had to miniaturize everything else. So it's basically the Atari's on this side, and the battery's on this side, and the cartridge and the screen are in the middle.
Well, I don't know that you would really want to make it that much thinner. I mean, considering you're using original cartridges anyway, you can only get it so thin. But it's, it's big enough for a decent sized screen and your hands fit on there comfortably. There's enough room for your hands, you're not blocking anything or...
There's actually, these parts could be made thinner.
Yeah.
But this couldn't because the screen and the cartridge are at maximum thickness. So, it's all right. That's why we did the indentation here. So we kept as much of it as thin as possible. Pew, 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 pew. Yeah, so it worked out pretty well, and I always wanted to hand wire an Atari 2600, and I tried it a couple times in the past and failed, so I'm glad I finally did it.
And it works. We were just playing games on it. So.
Yeah,
Woo,
berserk.
success!
Now it's time for a research update.
So I'm doing some prep work for a future project. The idea was submitted on the community and Karen found it. Basically, the idea is that we're gonna keep track of whether or not grandma's taking her medicine. So we have a pill box, which is gonna be on top of this weight sensor. And then the weight sensor will connect to this load cell amp and will go to the microcontroller. And then also we'll have a real-time clock connected to the microcontroller as well. So what we're gonna do is keep track of how much the weight changes over the week.
That's all the time we have for today, but I'm glad we finally finished the Atari hand-soldered portable.
Do you have any questions about Ben's portable Atari 2600? Let us know on the Element 14 community on element14.com/TBHS.
You can also read about upcoming episodes, builds, and other special events. We'll see you next time. I have created all of this misery for you, Bond, which I will make you now forget. I know what colors coordinate, I just don't care. Someone left my alien cake out in the rain. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.